Now, we also have the another basic function, which is the subtractors. Subtraction is also a basic arithmetic operation used in our digital computers. Review lang ulit. In our operation, subtraction of binary numbers, 0 minus 0 is 0, 0 minus 1 is 1, with a borrow. Siyempre, with borrow 1. Kailangan natin mag-borrow 1 from the next significant digit. And then, 1 minus 0 is 1, and 1 minus 1 is 0. Like our adder, we have half subtractor and full subtractor. Yung half subtractor natin has 2 bits lang, and yung output natin is the difference output and the borrow bit. Yung full subtractor naman natin, yung input niya tatlo na. We have yung dalawang bits, minuend tsaka subtrahend, tsaka merong borrow input. Okay, yung output nito is the difference and the borrow output. Design of half subtractors. Syempre, unahin natin would be the truth table. So, 0 minus 0 is 0 yung difference. May borrow ba yon? Wala. So, 0. 0 minus 1. So, hindi po pwede. So, yung kailangan natin mag-borrow 1. Okay? So, ang kakalabasan nito would be 1, 0 minus 1. That would be 1 yung difference. Diba? Nag-borrow 1 tayo kaya meron tayong output dito sa borrow. 1 minus 0, that is 1. Nag-borrow ba tayo? So, hindi. 0 siya. 1 minus 1, that is 0 yung difference, and 0 din yung borrow. From this, we can now make or draw the logic circuit. So, hindi na tayo mag-came up kasi 2 variable lang naman ito. Hindi naman kine-came up ang 2 variable. So, as you can see, yung output D natin is the same kanina sa adder. This also is an implementation of the XOR gate. Tapos, pagdating dito, yung B natin is hindi na siya iisang logic gate, no? It's actually x prime y pagka kinuha natin siya. 0 yung x, 1 yung y. So, yung b pala is x prime y. So, ito na yung ating functions. For our difference, it is x na naka-x or sa y. And for our b, it is x prime y. From this, pwede na natin i-drawing yung ating circuit. Ayan na siya. X and y, naka-X or D. Then, yung B natin is X prime, may NOT gate, Y, naka-AND, that is our B. Now, we have our half subtractor. Sa block diagram, ganyan lang siya. Kunyari, XY pa din gamit natin. So, we have the difference and then the borrow. This is half subtractor. Okay? Next, full subtractors. So, ganun lang ulit. We just have to plot out the truth table. So, 3 input variables na siya. 8 na yung combinations. And then, we also have to plot the output. And then, from here, we can now use the K-map to get the expression of each output. So, for D, nasan yung ating mga min terms? Ito siya. 2, 3, 4. So, yung una, 0, 0, 1, nandito. The next, 0, 1, 0, nandito. And the next is 1, 0, 0, 1, 0, 0. Ayan siya. The next is 1, 1, 1. Ito siya. So, parang katulad siya kanina sa ating adder. 2, 3, 4. Okay? And then for our, mamaya na natin gawan ng expression. For our output B, yung borrow output natin, nasan yung mga min terms? So, ito, ayan, 4 din. So, 0, 0, 1, nandito, and then we have 0, 1, 0, ito, and then we have 0, 1, 1, dito sa baba, and then 1, 1, 1. Ayan siya. So, pwede ulit natin tong i-groupings. Gawa na natin ang expression. For D, that would be x prime y prime z, or sa x prime y z prime, naka-or sa x y z, naka-or sa x y prime z prime. So, ito na siya. And then for B naman, that would be, ito is x prime z, and then next is this is yz, and then this naman, itong patayo is x prime y. So, ayan na siya. So, mayroon pa tayo dito masisimplify? Yes. So, sa sa D, sa difference, if we're going to take the first term and the second term, we can factor out yung x prime. That will leave us with y prime z naka-or sa yz prime. So, automatically, alam natin ito ay XOR. And then from here naman, sa third and fourth term, we can factor x naman. Ang matitira is y prime z prime or yz. Now, we know that this is XNOR. So, ayan siya. Now, from here, this format is x prime y naka-or sa xy prime. So, yung D pala natin is simply x prime, x XOR y, XOR to z. Meron na tayo. And then the function for the B, or the expression for B, is x prime z or x prime y or y z. So if I'm gonna factor out z here, ang matitira is x prime y, and we're gonna multiply it with 1. X prime, multiply natin with y or y prime. And then y, multiply natin by x or x prime. So magiging result ay x prime y prime, xy, and x prime y. X prime y will be equal to x prime y lang. And this, bring down lang natin. And then we can factor out itong x prime y. So matitira sa atin is x prime y or x prime y z, or z x prime y prime or xy. And now we also know that this is an XNOR gate. So this is our final answer. By the way, ito, no? Pag pinactor out natin yung x prime y, kaka-cancel out lang yung z and magigitong x prime y. So this is our final expression, x prime y or z and sa x XOR y prime. Ta-translate na natin to into our logic circuit. So the D is x naka-XOR sa y, ito siya. And then naka-XOR sa z, ito. So that's our D. Next is the B. So na-XOR na natin yung ito, di ba? Ayan siya, ito. Then ninat lang. So nandito na siya. And then naka-AND daw siya sa z. So ito, naka-AND sa z. Ito na yung second term ng ating function B. Ito naman, x prime y. Ayan siya, x prime y. And then naka-OR siya sa itong term na to. Diba? So now we have our full subtractor. As you can see, full subtractors and full adders actually employs dalawang half. Ito, half subtractor, half subtractor. Balikan nga natin. Ayan, no? Half subtractor siya, diba? May nadagdag lang na iba pang mga logic gate. Ito. Okay? So there are more adders and subtractors that we can also take into account, or we can also study this na magagamit din natin when we are employing a bigger kind of combinational logic circuit. So ano to? We have the parallel adder. This is basically an application of our full adders. So ito yung sinasabi ko sa inyo kanina, kinascade na natin siya. Kasi masyadong yung full adder, 1 bit lang naman ang ina-add nun eh. Usually pag nag-add tayo, nag-deploy tayo ng circuit, hindi naman tayo nag-settle into 1 bit lang, masyadong maliit. So ito is just to show you how does it look like if we are going to cascade full adders. In here, ang ina-add na dito is 4 bits na. So halimbawa, meron ako 1011 and 1100. So ito ay A sub 4, A sub 3, A sub 2, A sub 1, and itong sa baba is B sub 4, B sub 3, B sub 2, B sub 1. Okay, tapos mapapansin nyo, yung carry output ng first stage magiging input ng second stage. Yung tapos i-add dun sa second most, hindi second most significant eh, second least significant bit. Kakaroon yun ng sum, yung carry i-input dun sa, yung carry out i-input dun sa carry input nung susunod, and so on and so on. Kung gusto mo 5-bit, 6-bit binary parallel adder, so lagay ka lang ng lagay dito. Okay, so this is parallel adder. The only problem with the parallel adder is that we need to wait for some time bago natin makita yung final result, itong final sum. Tapos kung may carry, yung huling carry out kasi, di ba binibring down yan? Nandito. Okay, bakit? Ano kasi to eh, progressive yung pagsosolve nito. Uunahin niya dito, A1, B1, C1. Tapos before yon, sa kanya palang ibibigay yung carry sa dito, sa second full adder. Tapos magsosolve siya. Pag nagka-output si C3, saka palang mag-i-start si pangatlong full adder. Pag na-output na si C4, saka palang mag-i-start yung pang-apat na full adder. So, magkakaroon ng delay. Now, what if ang i-add ko is 16-bit binary parallel adder? So, 16 times yun. Kung may delay ito na, let's say, 10 milliseconds, so ito times 16 mo yan kung 16-bit. O, ngayon, kung times 4 lang, so ang total delay pala nito is 40 milliseconds. So we have to wait for 40 milliseconds before we can see the final result. Ito yung inaantay natin. Ito yung huling mag-a-appear. Si S4, sum4, tsaka si Cout. Now, for us, maybe 40 milliseconds is very fast. But remember that today in our digital circuits, in our computers are running in octa-core, 2.5 GHz, 2.6 GHz, 2.7. So 40 milliseconds is actually relatively slow because what we are already considering is in terms of nanoseconds na siya. Diba? So that's the main disadvantage of binary 4-bit binary parallel adder, or habang dinadagdagan niya ng dinadagdagan, pabagal ng pabagal. Okay? If we have a parallel adder, then of course we have a parallel subtractor. And we know that subtraction can actually be done using addition. Diba? By using the ones complement method or the twos complement method. Now here, in this example, in this circuit, what's being used here is the ones complement method. In ones complement method, what we do is ganito. Now imagine we have 2 digits na, let's say 1, ano ba ito digit? Ito 1101 minus 101. Ayan. So lagyan ko lang 0 dito para makita natin ang ano. Kung i-subtract natin to per bit, di ba? Starting from the least significant. So 1 minus 1, 0. 0 minus 0, 0. 1 minus 1, 0. 1 minus 0 is 1. Ito yung difference. How do we do that? And how do we do subtraction in terms of or by addition operation? So ang gagawin natin, kinukuha natin yung ones complement nung subtrahend. The ones complement of subtrahend is babaliktarin lang natin yung lahat ng bits niyan. So mangyayari pala niyan, pagka binaliktad natin yung bits nito is it will become 1, 0, 1, 0. Tama? So yan siya. Tapos i-add natin yun dun sa minuend natin, 1101. Pag in-add natin sila, so 1 plus 1 plus 0, 1, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 0. May carry 1. Sa ones complement method, yung carry, i-add mo pabalik. So, yung carry 1, i-add mo pabalik dito. Ayan. So, 1 plus 1, 0, 1. Carry 1. 1 plus 1, 0. Carry 1. 1 plus 1, 0. Carry 1. 1 plus 0 is 1. So, mapapansin nyo, the same lang itong dalawang ito. That is ones complement method. Kaya mapapansin nyo dito, bakit yung subtrahend naka-inverter lahat? Kasi that is ones complement. Bakit yung output carry ibinalik sa carry input? Ito na yon. Di ba may output carry tayo? Ibinalik natin dito sa carry input para mag-add siya dun sa 0111. Ang lalabas na sum, or since this is subtractor, ang lalabas na difference is yung tamang difference. Okay, now this is a 4-bit binary parallel subtractor. Anong itsura nito sa loob? Yung previous na pinakita nating slide. Ayan siya. Okay, so I hope na nafa-follow nyo pa.